In this video, we're going to cover how and why to create functions using Lua and use them to improve the organization, readability, and flow of our programs. Functional programming is a foundation of coding, so without further ado, let's go ahead and get into this. Let's start by taking a look at this example script. So here we're defining a variable to keep track of how many coins a player has. We're initializing the amount to 100. Then we're using a constant variable, notice it's in all caps there. And this is to define an amount of coins a player receives every time they open a treasure chest, right? That's the reason it's called treasure chest amount. And we've set this amount to be 25. So each time the player finds and opens a treasure chest, we add the treasure chest's coins to the player's coins, and we print the two messages that you see here, a congratulatory message and a message to inform the player of their updated coins. When we run the game, run this here, you'll see in our output that we have an output of 3 congratulation messages as well as 3 updated coin amount messages, right? It's repeated that 3 times. 1, 2, 3. Looking at our script a little more closely, we can see the exact same code is repeated 3 times. So each time the player finds a treasure chest, we're repeating the same exact 3 lines of code over and over again. So this breaks an important rule of programming called don't repeat yourself. Programming principle that's sometimes affectionately called the DRY principle, D-R-Y of course. It essentially means reducing repetitive code, especially if that code is likely to change. So what can we do to write code that's less repetitive? Well, we can use functions. So what is a function exactly? Function is a block of reusable code that can be used to perform a single task. So there's an emphasis on reusable here. We use functions in our code to break our program into smaller parts, make our program more readable, and to avoid creating repetitive code. Remember the DRY principle, don't repeat yourself. So now let's break down how to create or define a function. We'll go ahead and come down here and do that. So we start by using the keyword local and the keyword function. So local function, right? We then want to give our function a name using camel case as with variables. So this would be like function name. Then we need to have a set of open and close parentheses. You'll even notice that the editor is changing the colors of things to denote that it is recognizing them as what they're supposed to be. And then we need the end keyword at the end there, and you'll notice that Roblox editor, if I hit enter here, will automatically include that. And the end keyword allows our program to know, our interpreter to know when the function definition is done. So it'll start here and then it'll end here. And then anything inside here is code for our function. So we put whatever code our function needs to execute when called. Every time our function is called, it will perform whatever actions are put in here. So notice that the local and the end keywords are on the same level here, all the way to the left, and the code inside the function is actually going to be indented once. So that's 4 spaces, or just hit tab on your keyboard and that'll get you there. The other thing to note is that it is automatically going to be applied in a lot of editors, such as the Roblox editor, so you don't really have to worry about that too much. I think my keyboard is dying on me and it's typing double characters, but that's all right. All right, so let's go back to our sample code here. So instead of repeating these same 3 lines over and over, let's create a function, and we'll call this function open treasure chest. So we'll do local function, I'll say open treasure chest. We'll do our open and close parentheses. We'll hit enter, that's automatically going to give us our end there. And then quite simply, we just need to put these 3 lines of code inside of our function. And now actually go ahead and get rid of this. So we could also, by the way, call this function my function. We could call it a function. Like, it doesn't really matter what you call it. The fact is that it is much like a variable. You can name it whatever you want. But we want to make sure we're using meaningful names, both with functions and variables. What do I mean by meaningful? Well, the name of your function should make clear what the function does, just like the names of your variables should be a good description of what they represent. In my variables video, I was using the name x a lot there because it was pretty generic, right? I was changing it a bunch. It honestly wasn't a useful script in the first place, but naming variables with single letters like that is generally a terrible thing to do. For example, if this was x, and this was y, and this was, again, like my function. And then this would obviously have to be x, and this would be y. Tell me what this function does. Just by looking at it. You have no idea, right? I mean, obviously the print statement helps a little bit there, but you can see how this really makes no sense as to what it's actually doing, what it's trying to do. So we want to use meaningful names to make sure that we're getting more meaningful expressions here. So another thing to note about both function and variable names is that you have to start them with a letter, right? Like O, T, C here. You can't start them with a number, or you're going to actually run into errors in your code. So if we run our program now, nothing's going to happen. That's because we've only told the system that the function exists and what to do when the function is called, but we never actually called the function anywhere. We call a function by writing the function name followed by parentheses. So we'll do open treasure chest, and you'll see it automatically fills out here. I can hit tab, even gives me the open close parentheses. So whenever we call this function, the computer will run the code body inside the function's definition. We can do that as many times as we want. So an important note in Lua, you have to define your function before you call it. So I can't call my function up here because it's going to give us an error. You can even see an underline there for a warning, a yellow warning there saying it's an unknown global. It has no idea what open treasure chest actually is. And that's because we have to define it before we call it. So you can think of functions like recipes. The function definition teaches the computer how to complete a specific task. Once the computer knows how to do the task, you can just tell the computer to do the task. So once we've taught our computer the open treasure chest function, we can easily call the function multiple times in our program. So we were calling it 3 times before, we can do the same thing here. So this avoids repeating this same code over and over again and makes the code easier to read. So in addition to avoid repeating code, functions also help us organize our code and break large programs into smaller tasks. You might notice we're actually still repeating code here by doing these 3 lines, but you'll learn to avoid doing that in a future lesson. So if we run this now, you'll see that it gives us the same results here. So a couple more things to cover with functions. Let's talk about parameters and arguments. So a parameter is used to input information into a function, and this makes our functions more general and versatile. So to create parameters, you include them in the function definition, specifically in our parentheses here. So looking at our open treasure chest, let's say that we don't want to have every chest include the same amount of coins. We can go ahead and actually get rid of this line then. And instead, we're going to include a parameter inside of our open treasure chest function. Inside the parentheses here, I'll just call this amount. And this is basically a variable that we can use inside of our function now. So of course, instead of this, we can just fill in amount. And by using this name here, this parameter's name here, we're going to be able to feed whatever value we give our function directly into this amount variable. So now when we call our function, we need to include arguments or values for the parameters. So for example, let's say we want this first one to still be 25. We could have the second one be 50, and we can have this last one be 100. So our function is now both much more customizable when we call it, allowing us to decide on the fly how many coins the chest grants the player, plus it does make it a more general use function. And we can see now that we added 25, then we added 50, and then we added 100. And now we're not technically repeating the same code either. Finally, let's talk about another great use of functions. It's something that's called abstraction. So abstraction is simply hiding unnecessary details that we don't really need to know and only showing relevant information, right? So if we lower this down, you can see that we are opening a treasure chest at 25 coins, 50 coins, 100. This might not be the clearest thing this way, but let's look at something like our print here. So you may notice that we're using the print name followed by parentheses. If that looks like a function call to you, you'd be spot on. Print is actually a function, albeit a built-in one. It's a built-in function of Lua. And you can even see we're passing an argument into our print function, and we're giving it a string to print to the console, right? So this function is completely abstracting away all the inner workings behind the scenes that handle actually printing these messages to the console. But we can find this in the Lua documentation and take a look. So if we pull up the source code for the print function, this is at lua.org/source/5.1/print.c.html. We can see what's going on underneath the hood, so to speak. So the print function itself appears to be implemented in another programming language called C, which is a super powerful, now over 50-year-old language. It's crazy. Many languages, many programming languages can actually be traced back to C. It's still quite in use there. C's well beyond the scope of this series, however. If you are interested, we are doing some coverage of the C language in my other series, diving into the principles of computer science. So make sure to subscribe, hit the notify bell to be notified when those go live. The first of those episodes should actually be live now, in fact. So looking over this, it looks like a bunch of gibberish, absolute nonsense, and so much more code than you might think is necessary for a simple print statement. And that's why we use abstraction and functions to abstract all of this info that we ultimately don't care about, just to be left with this simple print name for our function. So a final thing to note about the print function is that despite all of the complexity behind the scenes, it handles doing one thing and one thing only, printing to the console. That returns us to the original wording of what a function is. A function is a block of reusable code that is used to perform a single task. So functions should really only try and do one thing and do it well. That doesn't mean you should only limit the code in a function to a single line, but more generally speaking, a more general overall goal that the function can perform. In our example, the goal is to handle when a chest is open. So even though we're updating the player's coins, we're printing a congratulatory message, and then we're actually printing the updated coin amount, which are technically three things. They're all happening because we opened a chest. These are all the things that happen when we open the chest. So functions are going to be used in nearly everything we do from here on out. So I hope you found this talk useful and are enjoying the series thus far. If so, make sure to let me know in the comments and appease the YouTube algorithm so more people can hopefully enjoy these as well. That of course means subscribing, hitting the notify bell, interacting in the comments as mentioned. So until next time, I will see you later.